Hello, everybody. How are you all doing? It's me, Mourad Sultan Ezouidi, a pioneer of methods and mathematical researcher in the field of solving and differential equation. Today, my kids, my students, will try to solve 2 to the power 11, okay, using the theorem or the second formula of Mr. Mourad Sultan Ezouidi. Okay, so let's focus on this method. Okay, so let's focus on this method, my kids, and we will solve 11th degree polynomial equation using Ezouidi theorem. Okay. I will now share the screen with you so that you can see the whole lecture, not only for kids or let's say students or learners, but also for professors, okay, and researchers. So today we will, let's say, learn from you and from Mr. Sultan Ezouidi how can you solve level differential equation using Ezouidi theorem. Okay, so let's start. This is our 1 to the power 11. Okay, I will use this system. I will use this one. Okay, okay. So you can see the lecture, professors and students and colleagues, and so my learners. You can see the lecture, it's before you, you can see it. Okay. So before that, this is open to the power 11. I'm going to start p of x equal x raised to the power 11 minus 33 x raised to the power 10 plus 495 x raised to the power 9 minus 4,455 x raised to the power 8 plus 26,730 x raised to the power 7 minus uh, minus 1,112,266 x raised to the power 6 plus 336,798 x raised to the power 5 minus 721,710 x raised to the power 4 plus plus okay 1,082,565 x raised to the power 3 minus 1,082,565 the square bracket plus my kids 649,539 x minus 6. Okay. So our polynomial to the power 11 can be written as that. Can be written as x raised to the power 11 minus L0 42 x raised to the power 10 plus L1 42 x raised to the power 9. This is 9. Okay. Minus L2 of 42 x raised to the power 8 plus L3 of 42 x raised to the power 7 minus L4 of 42 x raised to the power 6 plus L5 of 42 x raised to the power 5 minus L6 of order q x raised to the power 4 plus L7 of 42 x raised to the power 3 minus L8 of order q x squared plus L9 of order q x minus L10 of order q. Okay, so in order to find, let's say, the roots of this 11th degree from the equation, you should learn to use or apply the Ezouidi theorem, okay, that will help you to give you the new 11th degree from the equation, okay, means that you are going to search, let's say, the coefficients of our new 11th degree from the equation that is labeled as S subscript k minus 1 of order where k belongs from minus 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, up to 10. Okay? Meaning from minus 1 to n minus 1. And n denotes the highest power of all to the power of all equation, which is 11. So 11 minus 1 gives you the last coefficient of your new 11 11 polynomial equation. Okay. So here, okay. So here we start. These are the coefficients of my original 11 polynomial equation. Okay. Now we should, let's say, we should find, let's say, s minus 1 of 42 and s0 42 and s1 of 42 up to s11 minus 1 of 42, meaning up to s10 of 42. Means I was going to work out all the coefficients of a new 11 degree equation. After finding the 11th coefficient of your new 11 degree equation, because the coefficient starts from minus 1, meaning s minus 1 of 42 up to s10 of 42. Now I will use my theorem. Okay, so you can see that the sum, I will make bigger, better, and we'll see if this can better for you. 110%. Let's see, we are still waiting. Okay, I will put this up. Maybe. We'll wait, my kids. Okay, now it's a quick thing. So, here, my kids, I will use, of course, this one, I can put it down if it's possible. Down. Okay. So, I will use the decimal formula of Mourad Sultan Ezouidi or the theorem that is written as sk minus 1 over the r equals the sum from 0 to k combination n minus r with k minus r n raised to the power r between parentheses negative and 0 for g raised to the power q. Okay, so this is the formula. When k equals 0, I will obtain, let's say, s minus 1 over the 2 is equal always 1. Okay, this is the question. Or we use the theorem and replace k with a 0 and we obtain that is equal to combination n to minus 1 plus 0, which is equal to combination n to 1, which is equal to 1. So by convention, let's say s minus 1 42 is equal to 1. We continue. Now, in order to find the zero matrix, you should set k equals 0 in the Ezouidi theorem. Okay, or substitute k equals 0 in my theorem, which is equal, here we told 1. So, S0 of 42 equal combination, okay, combination k, I will make bigger. Okay. We told that when k equal 1, my kids, we'll try to find a 0 for the r equal 0 from 1, from 0 equal the sum from 0 to 1, combination n minus r to 1 minus r, 10 raised to the power r, between parentheses, negative 0 for the 2, raised to the power 1 minus r times lr minus 1 for the 2. After making our expansion, we will obtain that L0 S0 is equal to n minus n times L0 plus 2, whatsoever the value of L0 plus 2. So this one is always equal to 0. Okay, now we'll change this one because we changed the coefficient, the new coefficient. Let's see. Okay. This one. Make copy. Okay. This is this. I will erase this because these are the coefficients of my original 11 degree from equation. I will substitute or replace by the formula. Make control, make yes, make that. Now my kids, a 0 for the r equals the sum from equals in a combination 11 choose 1 times negative number, which is negative 1, times 33 because simply because L0 is 33. This one, of course, I'm going to erase it. So this one has to be equal to, we have 11 times 33. It will be 363. 363 plus 363. This one is going to be equal always to 0. This is a 0 of all the r or of all the q is equal to 0. Now, my kids, I should now find what? Find S1. To obtain S1, go back to the Ezouidi theorem and replace k equal to here. So it will be S2 minus 1, which gives you that will give you S1 for the R. The sum from 0 to k will be written as the sum from 0 to k. Combination n minus r choose k minus r has to be written as combination n minus r choose 2 minus n raised to the power r between parentheses negative 0.2 raised to the power 2 minus r simply because this the exponent k is k minus r, k is equal to 2, okay, this is 2, times lr and subscript r minus 1 equal to 2. So after explaining, after let's say simplifying this expression, there S1 has to be written in general. Okay, this is the general form of S1 for the R for any new algebraic equation relative to the original algebraic equation is negative combination 1 to 1 times combination n to 2 times 0.2 squared plus n squared times 1 to 2. Okay. So if you are working with second degree from equation, this one is the second coefficient of my new second degree from equation, which is equal to the negative sum of the discrete formula that we already know for quadratic equation. Okay. Now, my kids, I will just make enter like that, make copy and what, because I will change the coefficient of this one. Okay, I will erase this, my kids. Okay, so wait for me, my professors, so that we will understand how to solve 11 degree from the equation using Ezouidi theorem. Okay? Okay. Now, my kids, it's clear that, okay, that the value of S1 of all the R or Q is going to be equal to 0. I will change L0 with 33. You can use a calculator. And this one, L1 with 495. 495. So this one is equal to 0, my kids. If you want to use my calculator, I will use, okay, calculator. Where is calculator? Calculator. There is no calculator. This one. Okay, you can see that there is negative sign times 11 choose 2. 11 choose 2 is 55. Times what, my kids? Times 33 squared, isn't it? This is 33 squared. Okay. Okay, and 0, okay, plus 11 squared minus 400 times 495. This one equals 0, you see? So, so S1 is going to be equal to 0. We continue, my kids. Now, to find S2, just go and set K equals 3 in the discrete formula of Mr. Mourad Sultan Ezouidi, this one. as k minus 1 for the r equals the sum from 0 to k combination n minus r to k minus r and raised to the power r. The two parentheses will be reduced for the 2 raised to the power k minus r times l r minus 1. This, my kids, is my theorem that I discovered. Okay, the C's corresponds to the new 11, to the new empirical equation, corresponds or relative to the original empirical equation. This is a general formula. Okay, you will, professors, you will substitute K with 3 to find S2, and finding S2 and try to write it in its lowest term. This is S2 means the general formula for finding the third coefficient of your NPV equation whatsoever the degree of your polynomial equation. Okay, here it's clear that n equal 11. So I'm going to find S2. So this is S2 matrix. S2 equal 2 combination n choose 3 times n 0 for the 2 cubed minus combination n minus 2 choose 1 n squared n 0 for the 2 raised to the power 1 times n1 for the plus n cubed times n2. Okay, here, my kids, I will write the coefficient of my original 11 degree from equation. Okay, then I'm going to raise that this one, no need for this. Okay, okay. Then we should substitute the values of L R minus 1 for the Q in this formula. Means we will just use L0 and L1 and L2 only. No need for uh, the other coefficient because we are talking about the value of S2. Okay, I'll just like that. Okay, now I will substitute. You see, this is L0 is 33. I should change this one by 33. Okay, I make 33. Yeah, okay, this is 931 times 11 squared times 33. Okay, times L1, my kids, is 495. 495 plus 11 cubed times what? Times 4,000 and 4,455. This one, my kids, has to be equal to 0. Okay, let's use my calculator and okay, calculate the following. So 2 times, because this is 2, times 11 to 3 times 11 to 3 is 165. 11 to 3, 1 to 3. Okay, times 33 cubic times 33 raised to the power 3. Okay, minus 9 multiply by 121 because 11 squared multiply by 33 multiply by 495 plus 11 cubed 11 raised to the power 3 11 raised to the power 3 times 11 raised to the power 3 times 4,452. Okay. This one, my kids, has to be equal to 0. Okay. Of course, using my theorem. This theorem is now available for is available to be used. Okay, you can use this and solve and the equation. Okay. Now we continue, my kids. We should find out S3. To find S3, just go and use Ezouidi theorem. Okay, this one. So S3 just to K equal 4. I will obtain S3 for the R equal negative combination P choose 1 times combination N choose 4 N 11 times N 0 for 0 to the power 4 plus combination N minus 2 choose 2 N squared N 0 for 2 squared times N1 minus combination N minus 3 choose 1 N cubed times N1 times 2 plus N 0 to the power 4 times N2. This formula is a general formula to find the fourth coefficient of your new Euclidean equation that has a relationship between the original and the Newtonian equation. Okay, so I will now, my kids, write the coefficient, if possible. These are the coefficients of my Newton's equation, and I'm going to erase this one. I need for this. Okay, go right, if possible. Okay, remove. Okay. I will erase this, my kids. I will erase this. Okay. And try to substitute in S3 the coefficient of L0 with 33, L1 with 495, L2 with 4,455, and L3 with 26,740, and then figure out the answer. Let's do this one. Okay. I will substitute. Means L0 has to be equal to 33 raised to the power 4. Then this one is going to be 33 raised to the power 4. Then this is 495. Then this one is 33. Okay, we did. Then this one is 4,455 raised to 6. Raised to 6. Okay. Then 11 raised to the power 4 times, okay, 26,730. Use the calculator and we figure that this one is equal to 0. Okay? Okay. I will use my calculator if possible. Okay, first of all, go up. So that will be good for you. Okay. Go again. Right, if possible. Go up. So that the demonstration should be clear for you to solve and learn. Okay. So here I will use my theorem to find S3. I will start. You can see this. I will calculate this with negative 3 times 11 choose 4. 11 choose 4 means times 330 times 33 raised to the power 4. Good man. Plus 9 choose 2. 9 choose 2. 1, 2 means 36. There is minus plus, no, then plus 36 multiplied by 36 multiplied by 11 squared means what? Means 121 times 33 squared times 33 raised to the power 2. Why? Because this is 33 times 400 times 495 minus 8 minus 8 multiplied by what? Multiplied by 11 cubed by 11 raised to the power 2 times 33 times 33 times 4,000 times 4,455. Then plus 11 raised to the power 4 plus 11 raised to the power 4 multiplied by 26,730. So this one has to be equal to, and now let's check. Okay, this one is equal to 0. Okay, of course, using this is will show you how the theorem is very, very, very excellent. Okay, so now we continue. I want to find S4. To find S4, go and input K equal 5 in my theorem. Okay, then you will obtain S4 equal combination 4 plus 1 times combination n plus 5 times S0 42 raised to the power 5. Okay, minus combination n minus 2 choose 3 times n squared times L0 42 cube times L1 42 plus combination n minus 2 choose 2 n cube times L0 42 squared times L2 42 minus combination n minus 4 choose 1 times n raised to the power 4 times 0 for the 3 times n 3 for the 2 plus n raised to the power 5 times n 4 for the 2. This is general combination. Okay, to find the fifth coefficient of mu at the degree of mu equation. You see S4 is related to and you see this means you are working with and degree of mu equation. Then if you want to fix the n, now we'll write the coefficient. The coefficient of my origin and degree of mu equation, and I will erase all of this. Okay, we'll go step by step. Then we need to see how to implement this equation. It's not easy. Without using video theorem, you will be confused like this. Okay, now I will change the coefficient. This is of course in 11 raised to the power 5. I will make 33 because n0 is 33. Of course, this is going to be 33. 33. This is in total 495 raised the rest. This is 33 squared. Okay, it means I will use my formula and substitute L R minus 1 for Q with their coefficient, with their values. This is it will be 4,455. Okay, this is 33. Okay, this one. This is 26,730. Okay, yes. And this one is gonna be 111 and 112,000. 112,000. 266. Okay, this one, my kids, you need to include zero. Okay, here's the calculator. This is not randomly. Okay, you say any word now. This is theorem, strategy, method. Okay, but will lead you to find the exact roots of these 11 groups in this video. Okay, if you want your calculator, if you want to use your calculator, you can use and find the calculator here. Okay, so okay. So 4 times, I'll make 4. Also here, 4 times 5 is 1. 1, 2, 3, 4, 5. Means times 462, I think. Yes. Times 33 raised to the power 5. Times 33 raised to the power 5. Good enough. Then minus 93 means minus 84. Minus 84 times 11 squared means 121 times my kids 33 cubed raised to the power 3 times what? Times 495 times 495. Then we move to this one plus 852. 852 is 28. Means a plus 28. Plus 28 multiplied by 11 cubed times 33 squared. Multiply by 11 raised to the power 3 times the 33 squared times 1000 times 4,455 minus 7 multiplied by what? Multiply 11 raised to the power 4. Okay, multiply 33. Multiply by 33. Multiply by 26,000. Multiply by 26,730. Then plus 11 raised to the power 5 multiplied by 1,112 multiplied by 112 multiplied by 112,226, 266. Yeah. For my kids, in fact, it was zero. You see? Okay, let's continue. Now I want to find, let's, okay, step by step if possible. Step by step. I want to find my kids S5. To find S5, my kids, go and use Ezouidi theorem. Or go and use Mourad Sultan Ezouidi theorem. Just put k equal 6 in this one. When you put k equals 6, obtain S5, because 6 minus 1 is 5, equals the sum from 0 to 6, combination n minus r to 6 minus r times n raised to the power r times the derivative negative and 0.2 raised to the power 6 minus r times the r minus 1. So after expanding this and write this in its lowest term, we will come to write S5 as the following. Okay, minus, this is minus combination 5 plus 1, 11 plus 6, and 0 raised to the power 6, plus 9 plus 4, and square, and 0 raised to the power 4 times 1, minus 8 to 3, and 2, and 2 times 2, plus 7 to 2, and raised to the power 4 times, and 0.2 raised to the power 2 times, and 3.2 minus combination 6 plus 1, and raised to the power 5 times, and 0.2 raised to the power 1 times, and 4, plus n raised to the power 6 times n. Now, my kids, you can see that I will use the S5 to find what? To find the value of S5. Means this one is the general formula to find the sixth coefficient of new 11 degree new equation that corresponds to the original 11 degree from the equation. Okay? So, okay. Okay, like that. Okay, now my kids, I will go and change the coefficient, okay, in the formula. So, what is it? Yes, this one. Okay, this one, my kids, has to be written as 33. Erase this if possible and make the parentheses. Last, this is 33, 33. Then make parentheses, raised to the power 4. Okay, this is my next. Times what? Times 495. Okay, minus this one. I'm going to change need for this. I change only 33, 11 by 33. And this one comes here, Mr. Mourad, so that your professors and your colleagues and your students and your learners and so your kids watch and see how it was wonderful to use easily fair and equation. So this is 495, so the next can be written as 4,455. So this is that, make that is plus this, but I'm going to change this 11 by 33 square. Then after that we have 26,730. 26,730. 26,730. 26,730. Receive 33. Okay. Of course, multiply by 1,000. Multiply by 1,000. Sorry, 112,266. Plus 11 raised to the power 6 times 336,000. 798, isn't it? So this one is equal to clear. This one is going to be equal to is equal to Okay, let's calculate this. I will use my calculator. So we have negative 5 multiplied by with negative 5, yes, negative 5 multiplied by 11 percent. 1, 2, 3, 4, 5, 6. Yeah. 11 to 6, you told that is equal. Mm-hmm, mm-hmm, mm-hmm. 1, 2, 3, 4, 5, 6, 6. So multiply by 462. Multiply by 33 raised to the power 6. Multiply by 33 raised to the power 6. Plus 924. 1, 2, 3, 4. Plus 126. Multiply by 11 square. Multiply by 11 square means 121. Multiply by 33 raised to the power 4. Multiply by 33 raised to the power 4. Multiply by 495. Multiply by 495. Minus 83. 1, 2, 3. Minus 56. Yes? Now, while I'm busy. So, minus 56. Why? Simply because 8 to 3. 1, 2, 3. While I'm working, mister. Thank you. So, multiply by 11 raised to the 14. Okay. Then times 33 raised to the 14. Times 33 cubic. Okay. Then multiply by 4,000. Multiply by 4,455. This one. Plus 750 means 20. Plus 21. Okay. 21 times 11 times 11 raised to the power of 4. Okay. Times 33 square. Times 33 raised to the power of 4. I'll correct this. Multiply by, okay, 26,730. Okay. Minus 6 times 11 raised to the power 5 times 33 times 112,226. So we told. Okay, plus 21, we did this. 11 raised to the power 4, 33 squared, 26,730. Yes, now minus. Minus 6. 6 times 11 raised to the power 5. Good math. Times 33 only. Okay. Times 112. Times 112, 266. Okay. Again, 112, 266. Then plus, last one, plus 11 raised to the power 6 times 336 times 336,798. This one, my kids, has to be equal to 0. Okay? Clear. Secret. Clear. Okay. How comes here? This is equal to 33, not 4. Because a 0 is 33. Okay. Good. Now, I want to find a 6. To find a 6, you should put k equal 7 in Mourad Sultan Ezouidi theorem. Means in this, in my theorem. Okay, this one. Okay, this use no, no erasure. Because I use Mourad Sultan Ezouidi theorem. Ezouidi theorem. Okay. So we continue. We want to find a 6 with k equals 7. And we will find the last one. The 6 equals combination 6 equals 1 times 11 equals 7 and 0 over 0 to the power 7 up to n raised to the power 7 times l6 equals 3. Here the coefficient I will erase all of this. Okay. So it's not randomly how we got here. Okay. You understand after that this sorry, stop. Okay. So we'll note that after function, we'll see that this polynomial to the power 11 can be written as x minus a 3 raised to the power 11 plus something equals 0. That's why S1, S2, S3, S4 have to S minus because S2 has to be different. Okay? This is an example to let you understand how it is. When you got the same root with n multiplicity of order of multiplicity. Sorry. So now we change this with 33. Okay. This one with 33. Okay. Of course, this is, I'll make parentheses better. This is 495. This is, I'll make parentheses 6. Okay. I'll make this is 33. Close the parentheses if possible. Times 4 between parentheses, I'll make 4,455. Make parentheses. Then this one my kids is 33 cubic. 33 raised to the power 3. Make parentheses. Okay. Times what? Times make parentheses. Times 26,750. Okay, plus this is 33 raised to the power. Okay, make 33 here. Sorry. Make parentheses. This is 33 times we called 112,000. 112,266. No, the parentheses. Okay. Then I will use this delta. Then this is 33 cubic, 33 only. This one we told 336. 336,798 plus okay and 8 and 6. We obtain at 6, isn't it? Okay. So and 6 it will be 721,700 121,000, right? 710. Okay. So this one my kids is equal to 0. You want to calculate, or I will do this for you. Okay? I will do this for you, so that will be completely appreciated. So I'll write 6, because this one is 6. Times 11 to 7. 1, 2, 3, 4, 5, 6, 7. Okay, times 340. Times 33 raised to the power 7. Minus 925. 1, 2, 3, 4, 5. Minus 126. Multiplied by 11 squared. Multiplied by 147. Multiplied by 33 to the power 5. Multiplied by 33 raised to the power 5. Multiplied by 495. Multiplied by 495. Then plus 8 to square. 1, 2, 3, 4. Means plus 70. Plus 70. Multiply by 70, multiply by 11 cubic, multiply by 11 cubic, raised to the power 3, multiply by 33, raised to the power 4, raised to the power 4, multiply by 4,055, so 4,455, minus 73, 1 plus 2, minus 35, multiply by 11 raised to the power 4, multiply by 11 raised to the power 4, multiply by 33 cubic, multiply by 33 raised to the power 4, then multiply by 26,000, multiply by 26,740, the function after this, plus 622, 1, 2, okay, plus 15 times 11 raised to the power 5 minus 11 raised to the power 5 times 33 squared times 33 raised to the power 4 times 112 times 112, 266, minus 5, multiply, minus 5, multiply by 11 raised to the power 6, multiply by 33 raised to the power 1, means multiply by 33, multiply by, let's say, 336, multiply by 336, 798. Plus 11 raised to the power 7 times 721,720. So make plus 11 raised to the power 7, so this is 7, times 721, 710. So this one, my kids, has to be equal to 0. Okay? Okay. We continue. I want to find a 7. To find a 7, we will use this formula. Means you are going to put k equal to 8 in the discount formula of Mr. Ezouidi or the theorem of Mr. Ezouidi, and you obtain this 7 is equal to this. Okay? After writing it in Excel term. Means we will write 7 equal negative 7 to 1 times 8 is equal to 0 to the power 8 plus 96 and x squared times 0 to the 0 to the power 6 times 1 minus 8 to 5 and 2 by 0 to the 0 to the power 5 times 2 plus 2 plus 7 to 4 and 0 to the power 4 times 0 to 0 to the power 4 times 0 to the 2 minus combinations of 3 and 0 to the power 5 times 0.2 raised to the power 3 times 4.2 plus combination factor 2 and raised to the power 6 times 0.2 square times pi minus combination factor 1 and raised to the power 7 times 0.2 raised to the power n and 6 up to n raised to the power n and 7. I will now write the coefficient of my original 11 degree equation, which is this. So no need for the rest, just I will write them. Okay. Calculate the S7 matrix and retain the S7 then we equal to also S8 is equal to 0, S9 equal to 0, except S10, which is different from 0. Okay? Okay, now I will change this formula. You see L0 is 33. That's substitution. Okay, 33 with L0 42. Okay. This one is L0, which is 33. And you can calculate this. So this one, my fixed record is 4,055. Okay, before this one. Then the next, I will put equality looks better for the next column. Okay. Okay, from here, make 33. Multiply by, sorry, then it's not possible. Okay, from here, and write 33. So my professor, when you change, let's say, in this formula, and 0 with the 3, and 1 with the 3, up to and 7, then you change the let's say, okay, and you find the thing actually confusing. Okay, you need to do the theorem, of course. The only one method. We help you to find the coefficient of your element of your new element equation that corresponds to the original element equation. Okay? So this one equals is okay is 26,730 then okay 11 raised to the power of 4. This one I change this one. Okay, make 33 now again that 33. Let's use 11 33. And this one hits with 112,266. Close the parentheses. Minus 61 11 5 times the cube of 33. And this makes 19, 33, raise 1. On 1 only. Times, between parentheses, we have what? We have, after this one comes 336. 336,798. Erase this. Okay. Then plus this 11, the value of 0 is 33 in the example. I'll change this with 33. Come here, and erase this if possible. Make enter. Erase the 1. Okay, now the 1. Okay. Times, after this one, 33 will be 721. 721,710. Isn't it? Okay, that's Q now. Yes. Okay. Then this is 33 raised to the power 1. You can write it as 33 only times 1 million times 1 million and 82,565. Raise the rest plus okay plus 1 million okay plus 1,082,565. So this one you can calculate this you'll obtain that it's equal to 0. If you want differently this for you, I will do it. Okay? What do you think? No, no, what do you think? Professor, you can calculate this on your side? No? I'm waiting for your answer. Okay, I will calculate this for you. This is to show you that we are using my theorem that will give you the exactness with no estimation. Even you will never use the classical method like create method for that you will take an X subscript 1 for example as a guess, as a try, and we'll continue depending on the first page. Okay? So we have negative 7, we'll write negative 7 simply because why negative 7? Because in the formula is negative 7 should be times 11 should be 1, 2, 3, 4, 5, 6, 7. 7. This is 8. Again, A 11 should 8 means 1, 2, 3, 4, 5, 6, 7, 8. Means multiplied by 165. 165. Multiplied by 33 raised to the power 8. Oh my God. Multiplied by 33 raised to the power 8. Abnormal. Plus 96. 1, 2, 3, 4, 5, 6, 84. Minus plus 84. Plus 84. Multiply by what, my kids? Multiply by 11 squared. Multiply by 33 to the power 6. Multiply by 4,455. So, okay, multiply by 11 squared means what? Multiply by 113. Multiply by 33 raised to the power 6. To the power 6. Multiply by 4,455. Then we have minus 8 plus 5. 1, 2, 3, 4. Okay, we obtain here. We start with okay. Okay, go up like that. Again, again. We take it later like that. So we started. We started minus 8 plus 5 is 3, 4, 5. Means minus 56 times 11 cubed times 11 raised to the 4 cubed times 33 33 raised to the power 5. Yes, 33 raised to the power 5 times 26 times 26 times 730. Okay. Plus 7 to 4. 1, 2, 3, 4. Plus 35. Multiplied by 11. Multiplied by 11. Raised to the power 4. Raised to the power 4. Multiplied by 33 raised to the power 4. Multiplied by 33 raised to the power 4. Multiply by 112. Multiply by 112. 266. Yes. Minus 6 to 3. See, 150 means minus 20. Multiply by 11 raised to the power 5. Multiply by 11 raised to the power 5. Multiply by 33. That's 700 plus minus 4 minus 4 minus 4 times 11 times 11 raised to the power 7 times 33 only. Okay. So let's see. You solve. Let's see. Let's see this second. Okay. Let's see. Okay. You can see this here. Okay. Now my kids, go back to calculator. We found minus 4 times 11 raised to the power 7 yes, times 33 times 33 times 1 million times 1 1 million 82,000 52,565 1,082,000 plus control plus okay. Repeat this again, my kids. Okay. So we call negative 7 times 11 to 8. I will repeat this again. So it will be negative 7 multiply by so 11 to 8 1 2 3 4 5 6 7 8 multiply by 165. Then multiply by 33. Yes. The 33 multiply by 33 raised to the power 8. Then minus plus something, so plus 6 to the 96, 1, 2, 3, 4, 5, 6. Then 1, 2, 3, 4, 5, 6. Then the plus 85 times 11 squared times 11 raised to the power 6 times 33 times 33 raised to the power 6 times 4,150 minus 850. 1, 2, 3, 4, 5. Minus 56. Multiply by 11 cubes. 11 raised to the power 6. Times 33. Times 33 raised to the power 33 raised to the power 11 cubed plus minus 36. 11 cubed times 33 raised to the power 5 times 26,000 times 26,740 plus 750 plus 45 multiply by 11 raised to the power 4 times 44 times 33 raised to the power 4 times 112 256 minus 650 is minus 20 multiply by 11 cubed. Okay. 11 square, 11 3, 11 4, 11 square, 11 to the power 5 means multiply by 11 raised to the power 5, okay, times 33 times 50 cubed. Okay. Minus 336 minus 336 798. Then plus minus plus. Okay, plus 10 multiply by 11 raised to the power 6 plus multiply by 33 square plus multiply by 721 minus here multiply by 11 multiply by 11 raised to the power 7 multiply by 32 multiply by 1,022,000 1,000,000 1,033,560. There, correct. So we put that and 1,022,000. So 560. Then plus 11 raised to the power 8 times 1,022,000 Okay. Let me put this. Okay, it's going to be back to this one. Okay, okay. stop here. This is something. This will not happen. This is okay. Stop please. Stop here. I need to go down. Mm, So when you save this, then I'm gonna stop. Okay. Not save. Mm, okay. It comes now. And here. Okay. Wait, my kids will come. I will open it again. Okay, come here. Yeah, okay. Okay. Okay, it's a for this connection. Okay. Continue. Okay, this is my new. I'll change example number one because instead of writing doing example number three, so the kids is going up, so I'll do this example. Okay. Okay, I will change this coefficient because I will start with this one. Now this is 33. Now this is because one hundred and 95. This is 4455. Provide the coefficient of the individual. 1, 2, 3. This is 26, 26, 7, that's the first. This is 1, 1, 2, 2 double 6. Alright, okay. This is the back. Yes, 50, 6, 50, 6, 7, 9, 7, 9. Okay. And then this is 7, this is 7, yes, 50, 71, 17, 17. Okay. And then this is 8. Okay, 1 million. This is 1 million. 1 million. 82,000. 565. Okay. 1,000,000 into 565. So I have 1,000,000 into 565. Okay, this is it. Okay, my kids, listen very careful. Now, this is class. Yes, which original? Okay, this is okay. Which after 7 isn't it? So it's 7. So the coefficient. No, 2, 7. Okay, so this one is 7. Okay, this is S6. Okay, S6, if we found the physical degree. Okay, S7 for K equal to K equal 8. And make bigger, then inside the expression, and 14 again. Okay, no problem. Remove only to S7, isn't it? Okay, S6, S8, this is S7. Okay. Yeah. Okay. We go back. When it comes to this S7, let's continue, then I will go to this one. Okay. So we have for negative 7, 11 choose 8, and 0 to the power 8, and 9, 6, and squared, and 0 to the power 6, and 1, minus 8 choose 5, correct, and cubic, and 11 cubic, 33 to the power 5, and 2 here, and 2 yes, okay, to the okay, the 2 is 4,000, yes, so, yes, this one, my kids, is not, it's not for, this is 495, sorry, this is 495. 495. Okay, because in the formula times L0 to the power 6. L0 to the power 6 times L1. L1 is 495. Then this one it will be 44. Okay, 4455. So this one. Okay. This one becomes 26,000. 26,730. Okay. Then after this one, 111,000. 111,000. 266. To concentrate to the picture. Then after this, 3. After this, we have 336, 798. Okay. Now 336, 798. After that, we have here. Okay. After that, we have 72,000. So 721, 710. Okay. This one. The formula comes with the L7, isn't it? L7 is that. This is L7. Okay. Now we calculate this and we'll see that is equal to 0. Okay. What is the calculator? This is the calculator. Now, I will now, okay, let's take it from the beginning. Okay. We have -7 multiplied by, look, 11 choose 8. 1, 2, 3, 4, 5, 6, 7, 8. Multiplied by 165. Multiplied by 33. Multiplied by 33 raised to the power 8. Okay. Plus 96. 1, 2, 3, 4, 5, 6. Plus 84. Multiply by 11 raised to the power 2. Means this 2. Okay. Multiply by 33. Multiply by 33 raised to the power 6. Okay. Times my kids 495 times 495. Then minus 8 to the power 1, 2, 3, 4, 5. Minus 56. Multiply by 11 raised to the power 5, 8 is 56. Multiply by 11 cubic. Multiply by 33 raised to the power 5. Multiply by 4,155. Minus 56. 11 cubic. 3 okay. Plus 74. 2, 3, 4. Plus 35. Multiply by 11. Okay. By 11. Multiply by 11 to the power 4. Multiply by 33 to the power 4. Okay. Multiply by 26. 26,710 and 20. Okay. Minus 60. 150. Minus 20. Multiply. Minus 20 multiply by 11. Multiply by 11 raised to the power 5. Multiply by 33 cubic. Yes. Then 10 plus 10, 5 plus 10 multiply by 11 raised to the power multiply by 11 raised to the power 6 multiply by 33 squared. multiply by 336,798. Minus 4 multiplied by 11 raised to the power 7 multiplied by 33 multiplied by 721 710 that again then plus 11 raised to the power 8. Okay, that's 1. Okay, we have negative 11. Okay, plus 6 7 square 33 minus 85 6 11 8 4 3 2 1 9 85 11 12 23 and then we have 26 over 30 after that 11 56 after that we have 3 26 79 after that we have 71 71 10 and then we have the remaining 82 165. Okay. So this one is equal to 0. Okay, let's continue. Anyway, okay. 11 minus 7 then 11 minus. Okay, now move to the next part. I will erase this one. Write minus coefficient. Okay, I will erase this one now. New. Here also we'll find the c is equal to 0. Okay. Outside this one. This is my kids is 33. Okay, this is 33. I'll change that to the coefficient. 33. This is the currency is 495 only. So this one and this one is 33. 33. Right, this one. Okay. Mm-hmm. And that. This is 4,000. Okay. Okay, 4,000 and 465. Then we have 26. Yes, 26 is 33. Raised to the power 5. Then this one will be 26,000. 26,730 and 20. And this one. Then this is 20, this is possible. 20, 33, because I do. Then this one it will be 112, 110,000, 166. Okay. And this one, my kids, is 33. Okay, minus 33. And then this one, I give more easily. It's a plus. And then 23. 23. Then this one, and then 23, 26. 26. And 26. 7, 19. 7, 19. And then this one. And then more. 26. Okay. After that, we have this one. 20, 22. And then this is 33. A little more. 51. Okay, this is what. And this. Continue. Listen. 7 years 9 is 9. Okay. Let's think on this. We'll wait matrix. We continue this example. Okay, this is another this. Okay, finally it works. The keyboard doesn't work. Wait, down. That's fine. I can do it now. Okay, so okay, no problem. I will use this one. Let's see. Okay. Yes, we are here. Here. Now for my keyboard, I will have to use this. Okay, so this one I will erase. And this, and this. Now, let's see. Okay. Maybe. And this is three. Now this and 33. This one is 3. Okay. And then only one 3. Only one. Okay. So this one, erase this and make half 7 to 1. 7 to 1. Divided by 7. 1. This is 512. We can that. Okay. Then 7, 10. This is 7. This is 10. 2, 0. Okay. Then this is 33. From here. 23 from here. Okay. And this. And that. This is 38. When typing 3 comes up. Okay. So the next we have 1,000,000 and 82,565. Okay. And the last one, 11 raised to the power 9 times n 8. And 8 is 1,000,000. This is 1,082,000 and 82,000 and 565. So this one, my kids, is going to be equal to n. Okay. Okay. This one is equal to n. We continue. Now I move to S10. This one. I will make enter. Enter if possible. If you control V. Did. Now arrange this in me. Okay. Now comes here and change the value of L0 and 1 up to L9. Okay, this is the formula: L0 and 1 and 2 and 3 and 4 and 5 and 6 and 6 and 7. And 6. So my kids, I have put in my laptop. So tomorrow we try to continue. Okay, we continue this evening. So we put this here. And we use control U. Okay, we use the coefficient. Okay. Now we change this one matrix. This is 33. 33. Okay, this is also 33. This is 495. This is 33. I will change the coefficient. This is 4,000. 4,000 million 155. This is 33. Okay. This is my kids is 26,000. 26,720. Okay. This is 23. This is okay. So this is 130, 111, 120,000, 166. And this is 33. And then this one. Okay. 326, 798, then I'll change this to 33, then the next coefficient is 72, 72 means 721, 710, and then I'll change this one mean, okay, yes, 33, 50 minus, and here, and this one, times we got 721,710, we obtain 1,082,565. This is 33, 33, sorry. And this one is the same, 1,082,565. And the last one is 49. We can use the calculator for 64, 64, 649,539. Now we can use the calculator to find the series equal to now. Okay. I will check now the powers. So 10, 8, 7, 6, 5, 4, 3, 2, 1. Correct. I will just change the coefficient of this matrix. This one it will be, this is L5, L6, this is L7. This is L7, yes, I change this one. This is the formula. Okay, my kids. See you until next time. I will continue this tomorrow. I will repair my laptop first. Then I will continue this again. Okay, thank you and goodbye. I just thought I have put in this keyboard. So thank you for listening. See you inshallah tomorrow inshallah. Okay. Remains only two steps to continue solving this question, but I have room in my keyboard. I don't know if you see this one. I don't know if you. يلا see you inshallah.